with 9.5 and things like create policy. So the idea with RLS is to have a view that's different for different users, right? Views that are of the data that are different. Now you can think of this as a filtering mechanism. That's one approach. But if you filter things in the right way, you can actually end up having two different sets of data, right? For the different users, right? You could have a set of data that says, so-and-so is a really nice guy, and you can have a set of data that says he's a really bad guy. And depending on who the person is that's logged in at the time, they may get one or they may get the other, right? There's all kinds of interesting use cases around that. So the whole idea here is that you're filtering and limiting, but you're providing a different view, right, for each individual that is connected. And we're going to do all of this while maintaining the relational consistency and all the normalization and everything that you normally get. You still get all of your primary keys, you still get all of your indexes, your foreign key relationships. All of that we still have while we have this RLS capability. The other really important thing from a security perspective was to make sure that we always require policies to be applied. So this is it is and it isn't, right, in the way it works inside of Postgres. And I'll get to that a little bit later, but you want this default deny approach. You want to have and make sure that policies are actually getting applied, because otherwise, you run the risk of people being able to circumvent the system, and we don't want that. So the first way that people had done this before was with security barrier views. Maybe not the first, but it's certainly a very common use case. A lot of people have already done this. They've implemented it this way. And the way they do that is to build a table or build a view over whatever table it is. Postgres had some problems in older versions prior to having a security barrier as an option on a view, because what could happen is that a given conditional could end up getting pushed down below the quals that were in the view, right? So I could have my really, really cheap function that gets called, and that happens to be called prior to any of the quals inside of the view get called, and that's really bad, because that little function might just spit the data back out, right, that it's being passed. And if that's happening first, that's a problem. Security barrier views fix that, right? With security barrier views, what you can do is you can say, okay, these quals must be applied prior to any functions being run. We actually changed that a little bit on 9.5, which I think is really interesting. But what we did was, it was work done by Dean Rashid. What he did was, he was saying, okay, we're going to change this so that functions can actually be pushed down if they don't receive any data from the view, from the table that's being referenced, right? So this could be, from the table that's in the view or from the table that's in the RLS policy, right? That has the RLS policy applied to it. Because if the function isn't getting any data from the table, then it's okay for it to be pushed down to the same level and be used in optimizations. And where this becomes really, really handy is when you're doing filtering on things like current time or date or any date, right? Because previously you couldn't push that down because it was a qual that, with a function that was not considered leak-proof. And I'll talk about leak-proof a little bit more later. But the whole idea here is that security barrier views were one way of getting the same kind of functionality, and RLS is actually built on top of security barrier views. So we talked a lot about the kind of select side of getting data out of the security barrier view. One of the things that we added in 9.4 was this with check option, right? So the with check option allows you to have views that are automatically updatable, but, well, we already have views that are automatically updatable, but the with check option says only allow a record to be added through this view, either as an insert or an update, if the result of that row could be visible through that view. Does everybody kind of understand that, right? This means that you can't insert data through the view that you don't get to see through the view. Right? It's actually a SQL standard capability, and we've implemented it in the SQL standard way. Right? And what we did was we actually combined this with, this was one of the other bases for the implementation of RLS, because with RLS we needed the same thing. Right? We needed a way to say, okay, we need to have policies that say, okay, you cannot insert data into this table that you are not allowed to see. Right? So it's the exact same kind of capability, and what we did was build on top of that with RLS. Cascaded versus local is essentially you can have sets of views that are on top of each other. right? And with check cascaded basically says that you have to be able to see that data through all of those views. Whereas with local, you can say, okay, maybe this other view makes it so that you can't see it, but that's okay. As long as the top level view says you can, then we're going to go ahead and let it go through. Again, this is all SQL standard stuff. This doesn't really apply on the RLS side of things because we're only dealing with one table in RLS world that we're dealing, at a time anyway. And so it doesn't entirely apply, but the way that you get this capability is just simply add the with check option onto your simple automatically updatable view. So one of the other things, just let everybody know if you have any questions, please. I'm more than happy to take questions or comments during the talk just in general. So please shout out if you have anything to say. All right, the next is the multi-schema approach. A lot of people have used this approach, and I'm sure a lot of people have hated it because it's ridiculous. You have to have all of these independent objects in all of these different schemas, and they all have to be the same. It makes it very difficult to maintain consistency across all of them. Updating a table definition is just a nightmare. And so there's a lot of problems with this. And you also end up having to put like massive views or inheritance across all of these because maybe you want to be able to do reporting across, So I've seen a lot of cases where people are like, well, I'm going to have a table per customer, right? Or a schema per customer, right? And it gets to be terrible. So my 2 cents is don't do that. But now RLS provides a way of getting the same kind of functionality without having to go down that route, right? Which is the idea behind it. All right, so the next thing to discuss is, let's talk about what we have in Postgres now in 9.5. So the first big thing, and I want to point this out first, I feel like a lot of people would jump right into creating policies and whatnot, but it's really important to realize you actually have to enable, right? You have to turn on RLS on a per table basis right now, right? Ways that you can address this in a security conscious system might be to have event triggers, which are now in 9.5, and this is something I'm planning on looking at, require that every table have RLS enabled when, at the end of the transaction or something along those lines. That's the kind of thing that event triggers are going to allow us to do now that we have them. So those plus deparse, which we might have to have, are things that we would need to do. But the whole point here is you have to enable RLS for every table that you want to have row-level filtering applied to. And what that does for starters is that says all access to that table must now go through a policy. All right? So this is getting back to that default deny approach, right? And if there are no policies on the table, we create one, right? We don't store it anywhere. We create it inline during the actual query rewriting, and we just say false, right? Essentially, right? So there's just an automatic default deny policy. One of the things that's really key to understand here, though, is that table owners, who are the ones who control the policies being applied to the table in Postgres, because table owners control everything with objects in the database today. Believe me, I want to change that someday too. But right now, they control the policies, and therefore they are automatically excluded from row-level security even when it's turned on, right? So if you alter table on and you're the owner, and then you query the table, you are going to see the rows, right? This also means that things like pgdump work, right? It's really important that pgdump works, for regular users and as well as for super users. That's the other thing. Row-level security is not applied at all for super users by default, right? I'm going to talk a little bit about ways you can make it happen, but just realize that that's the case. So the other thing is that when you disable RLS for the table, the policies are no longer used, but they're still in place, right? The policies still exist on the table, so you can just disable and re-enable RLS on a given table whenever you want. Of course, realize that if you disable policies, disable RLS on the table, anybody querying that table is then going to be able to see stuff in it, right? So just be aware of that. That's, or at least if you do that in commit, right, then other people will see that. So it's not like a per session thing. Instead, what we have is something called row security. So row security is a new GUC that got added along with RLS, which allows you to control this behavior principally around table owners and super users. So what you can do is you can set row security to on, which is normal, and we do the normal RLS stuff that I've been talking to. You can set it to off, which says never ever apply RLS. However, what that means is that you're going to get an error back instead, right? If you don't have rights to bypass RLS on that table, you're going to get an error thrown back at you. Because we don't want you to just be able to say, I'm going to set row security off and then no policies apply to me, I can see all the data. No, that doesn't work, right? So this is something also that pgdump does by default, right? pgdump by default sets it to off, and the reason for that is because when our expectation is that when you're using pgdump, you want to be able to see all the data, right? You're doing a backup, you shouldn't, you probably want to be able to see all the data. Now that said, there is an option to say pgdump, set row security to on instead, so that you can get a dump of just what is visible to you in the system. The last option, yes?
Who can change this option?
Anyone can change this option. Yes, because if it's set to off, and you try to run a query where RLS would have been applied, and you are not either the table owner, the super user, or you have the bypass RLS guck, which I'll talk about, then we throw an error. You don't get any data. You don't get. We just throw an error.
Yes. But if you ran pgdump, then would that pgdump throw an error?
If you ran pgdump with this set, well by default, yeah. Yeah, if you run pgdump by default, or exactly, it will throw an error, yes. Yeah, if it comes across a table that it can't read the data in because of the policy, yeah, it'll throw an error today. Which is why there's an option to say, go ahead and allow it to do that and allow me to get filtered results. But this was principally because a lot of people felt that pgdump's primary focus was doing backups. I realize that, yeah, that's certainly a huge use case for it. I actually think it's more generalized than that, but whatever, that's fine. The other option is force. So what force does with RLS is it says, even if I'm the table owner or I'm the super user, I can force row level security to be enabled for me so that I can see what happens. Right? This is kind of a debugging kind of tool, right? I want to force RLS to be enabled when it would apply to me. And I'll talk a little bit because different policies can be applied for different people. I'll talk about that in a minute. But the whole point here is that I want to be able to do kind of like debugging and whatnot. So I can set it to force and then policies get applied for me just as if I wasn't the table owner or I wasn't the super user. Any other questions about row security, Guck? All right. So let's get into actually talking about creating policies. Okay, so policies are table specific, right? And their namespace is also per table, right? And the way that it works is that you create a policy and you have a whole bunch of different options for creating that policy. Okay, the different options that are available here are for, and then we have a whole list of commands here, right? So this says that for a particular kind of command, a particular kind of option, like a select or an insert, we can apply this policy only in that case, right? So we don't if you use all, then it'll apply for all cases, okay? We'll talk a little bit more about why that matters. But to role name says, I want this policy to be for this role, right? Default is public, but you can set it to a specific specific role name, all right? And then we have using and with check expressions, okay? The using expression is the expression that we use to filter rows, right? This is kind of your notion of what's visible, okay, to this particular, through this particular policy, okay? With check is just like it is for security barrier views. The idea of with check is that this controls what's allowed to go into the table, right? So you have to pass the with check option to have this data be allowed to be added to the table, right? And that's true for either inserts or updates. The reason that we have both of these is that for some of these commands, actually for most of them, you only get one or the other, right? So select only takes a using expression, okay? And of course, if you use all, then you can specify both because it applies, it'll just do what's right. However, for insert, only with check applies, right? It only makes sense to have a with check policy for an insert. Update, however, gets both, right? Because update, the using piece is what rows is that update allowed to operate on that exist in the table today, and with check is what rows are allowed to go back in as the result of the update, right? Yes? Yes. Yes. So this expression is a generalized expression and works basically the same way a where clause does. And that under the covers is what we actually just end up doing. We just shove it into the where clause. So you can put pretty much anything that you can put into a where clause there. Now, of course, what that means is you can't put like aggregates in there. You can do a subquery, right, and get the results of that and stick it in there, but you cannot use an aggregate function directly inside of a policy. Yes, sir?
Do you have a table alias on table names in that subquery reference the table? In other words, if you want to say you're only allowed to see stuff here where this column equals some correlated thing on this table.
So, okay, yeah. Any columns that are used in here are expected to be references to the table. They are references to the table. So you can just say, using, I have some examples that'll probably help. But the short answer is, I think, yes. So we'll get to that in just a minute. Let me make sure I covered everything else on this. Yeah, I think I did, okay. So here's an example policy, right? And what I'm going to do is I'm going to use the same policy the same effective policy for a whole bunch of different ways of creating policies, right? So I'm going to start very simple and get more and more complex. So this is a very simple policy, right? We're creating a policy named P1 on a table named myTable. Now again, P1 is a name that's inside of the table's actual name, namespace for policies on that table. What this means is that you can have the same name policy for a whole slew of tables, right? Which makes things a little bit more convenient for scripting and whatnot, right? The next piece is this using clause, right? So using my user, so my user in this case is a column inside of the table, right? I think that answers your question about the alias.
Well, I was thinking more in the subquery case. How do you correlate if you're doing a subquery to other things?
You just reference the column just like you would otherwise. I mean, you might, that's an interesting question about if there is a risk there that you can't do it because of visibility concerns.
Yeah, I'm just thinking there's a lot of cases where you can try to apply this to a case where I've got relational data and I've got, say,
Yeah, that's probably a good idea. Yeah.
here, but I want to actually control it by some attribute on the first table, not on the actual table I'm controlling.
Well, okay, I think I get what you're saying. I mean, what you can do is you can say my user equal and then have a subquery here. Yeah, that works. Right? The issue, though, is that if you wanted to reference this column inside the subquery where you're doing a join to some table or you're doing a lookup in some other table that has the same column name, it might end up being ambiguous. I'd have to look. If it does, Postgres will spit it back out at you as an error, right? Which is obviously not terribly helpful. It might be a way of dealing with that, but it's a good thought that I should probably, that might be something I can get in for 9.5 is to make it so that we can have an alias to this, like current dot whatever. But then, of course, we've got to look for, what if you have a table called current? So I'll have to think about that. Because we wouldn't want it to break if you wanted to actually use a table called current. Actually, that might just work. You know what? I have to look.
You can do the alias on the insert table now.
Yeah, it might.
You can do the insert on the alias. Or you can alias the insert table now.
You can alias the insert table?
Yeah, when you're doing the...
Okay.
I'm thinking of...
Yeah, actually, you know what? My table, actually, I think that might just work already.
Well,
I'd have to look.
I was thinking of the...
I can't remember offhand. Sorry. It's been a little while.
The insert stuff.
Yeah.
But you can...
Right. Yeah, no, you could do something like that. Yeah. But that's a good point. We could just use this table name. And I think it actually probably would just work. I'd have to look. I'd have to go back and look. Sorry, I don't have an answer for you right now about that. It's a great question, though. I've given this talk like 4 times. That's the first time I've ever had that question come up. That's fantastic. Anyway, so moving on beyond this simple one, right? So this, again, is the same policy that we had before. Now I'm adding more things here. So these two are equivalent, right? They're exactly the same. When I specify using, if there is not already or if you haven't specified a with check clause, we take the using clause and apply it for both sides, right? Just kind of like a with check is done for the view by default, right? Same kind of thing. And so these two end up being exactly equivalent. So moving on, now I've added this for all here, right? So all is the default, all types of commands, but you can change that to be select, insert, update, delete, whatever you want to do, right? Now I'm saying to public. So to, again, this is for specific roles. By default, it goes to the public, it goes to public, which means all roles. One of the big reasons we added the ability to specify roles was because of performance considerations, right? You may want to be able to have a bunch of different policies on a table that are for specific roles, And to have to do that with just the policy by itself would mean that you'd have to do extra lookups and other work. And so it seemed like a common enough case that we wanted to add explicit syntax and capability for it. So that's what it means now. So moving on, we're now going to do specific policies, right, for specific commands in particular. So this is a select policy. And again, this is a case where you can only say using. You can't say with check. But this means that it's only going to apply for queries that are doing selects against the table, right? So essentially, queries that are getting data out through a select command from the table have this policy applied to them. So insert, again, only works with check. You can see that this is how you would specify a policy for an insert-based approach. And then this is the one case where you can have update policies. Right, so this is kind of an interesting use case, and a lot of people, we've been kind of mulling over this question about if it makes sense to have these kinds of capabilities. So this one allows you to give away rows, right? So you can only operate on your own rows, right, through the using clause, but when you have with check equals true, that means that I can update that to have some other name inside of my user as the result of the update. And so I can give my rows to someone else, right? I actually think that that is a pretty pretty reasonable use case in a lot of scenarios. Maybe you're in a hospital, right? And doctors are only allowed to see their own stuff, but they can give stuff to other people, right? Other doctors. You'd probably have some other policies and other restrictions around it beyond just this simple one, but the idea stands, right? I think it could also be very interesting for queuing systems, right? You're passing things between different queues. You could do that with RLS. Yes? Old or new annotation? No, I don't think so. The using, well, I basically no, but but using is only going to be for rows that exist in the table, and with check is only going to be for rows that are being added. So you kind of implicitly have that distinction, but you cannot have a with check policy defined against what the old rows in the table were, if that's what you're asking. But I don't think, that's what using is for. You filter those rows if you don't want them to be able to do it. Now the interesting thing here is that you can do this in reverse too, right? You could have using be true and then have some clause on with check. Now that is kind of a more interesting question of, is that useful? I have a hard time seeing a use case for being allowed to update records which you don't have access to, right? These would be blind updates. Now, technically speaking, we allow that through the grant system today, right? The grant system, you can grant update without granting select on a table. However, because conditionals, inside of a where clause, if you're referencing any of the columns in the table, if you don't have access to those columns, you can't use that conditional. So the only updates you can do through the grant system today, if all you have is update, is the whole table. Right? That's just how it works today. So it's kind of an interesting twist, if you will. So there's still very much an open question about whether it's a useful use case, but for now it's there.
It sounds like it conflicts with the philosophy you mentioned before of not allowing inserts into tables that you don't have visibility to.
Well, it does. However, you'd have to configure it that way to have that problem, right? So it's really a question about whether the flexibility is useful to have. Right now we have the flexibility that you can put anything in these things. What we could potentially have done instead was say, here's a select policy, you only get to have one using policy for all operations on that table, right? But I actually kind of like the flexibility because I think that would, then we'd probably want to do the same thing on with check, or if we didn't do the same thing on with check, then that would be weird, right? And so I actually feel like this is it's very simple and easy to explain, which I think is perhaps good enough reason just to keep it the way it is now. Any other?
Someone might also find a creative use for that.
Absolutely. I think it's possible. Maybe in your queuing system, you're allowed to acquire rows from another queue, right? And then make them visible to yourself to operate on, right? Maybe that makes them invisible to the other guy. You could do something like that rather than, it's more like a pull model instead of a push model, right? I could see somebody building a system like that, potentially using these interesting capabilities. All right, moving on. So here's a delete policy, pretty standard stuff. So actually, yeah, so let me touch on two things, right? So the delete policy here only has a using clause because you only are looking at rows that exist in the table, right? You're not adding any rows back, right? The with check is not about modifying existing stuff, really. It's about what rows are allowed to go back into the table. So that's why delete is a using clause. What this also points out, though, is that update takes a using clause, and that allows what the visibility is for the rows that you're updating, right? And that allows for visibility for the rows that are in the table to the update command. So some of you may realize that delete and update and insert all have returning clauses, right? So if you did set up a system, for whatever reason, where you were allowed to update rows that you're not allowed to see, right, through the select policy, you can still see them because you can have a returning clause that returns those rows back to you. So again, this might actually be a good thing, might be a bad thing. It's definitely a thing, and it's something important to understand, right? These using policies are what is this command allowed to operate on? And anything that command is allowed to operate on is also something that command could potentially return back to the user, right, through a returning clause. So if you had a delete policy that said that they were allowed to delete rows that they can't see through the select policy, they could use a returning clause and still get them back. I don't really see too much of an issue with this, but I'm certainly curious if anybody has any feeling about it one way or the other. So certainly something that we can consider, but it's a thing.
It does seem like, if they're not allowed to see the rows, but they can delete them, let's say, then the fact that they get a returning means they get confirmation that those rows actually existed.
Yes.
Right?
Yeah, absolutely.
Whereas if they couldn't do that, then they could blindly do that delete, and they know that if there were any rows, they're gone, but they would never get to see them.
Yes, but they would actually be able to see how many rows got deleted, right? And if only one row got deleted because they're using a primary key, then they would know based on the where clause that was there. You know what I mean? You can find out all kinds of wacky ways to deal with that, or to have that kind of a problem. But personally, blind updates and blind deletes are not things that, I think if you create your policies that way, you either did it for a really good reason and you understand the results, or you screwed up, which I think is far more likely. Was there another comment? Sorry, a whole bunch. Yeah.
These blind, these count the number of blind row. Sorry. These pop-up channel attack is requirement was extremely secure system like a military system. So these cases, as Stefan introduced at the beginning of session, schema and separate table-based security are needed.
I think if I understood the comment correctly, what you were saying is that if you needed to be able to do something like that, you could go use one of the other approaches. Yeah. Okay. All right. Fair enough. Yes.
If you've got an update that's returning, can you potentially just update it a single column and then return all of the columns?
If you're allowed to, yeah.
Maybe the person that's actually doing it, you didn't want them to see all of it?
That's why we have column-based permissions. I implemented that before. So you can on a per column basis deny access, right? That's completely independent and will still work just fine, but is completely independent of RLS.
Yeah, but if you go back to the example I was talking about before, you're deleting 3 rows based on some key that you know, obviously, because you know the key that you're passing in.
Actually, you need to have permission to see that key,
Okay, well, let's say you have permission to see,
all the columns.
you might have permission to see some of the rows of the table based on RLS already, right?
Yes.
So you can see all the columns of the rows that you're allowed to see, but I'm allowed to delete some rows that I'm not allowed to see, right? Based on some column, but I can return all the columns when I do that, so therefore I can see data that you never wanted me to see.
Right, if you set your policies up wrong. I think the biggest question there is, blind deletes, are they a thing that we should be trying to encourage people to use? And if so, should we try to put in protections to protect them from having that happen. And I'm like, I really, if you want to do a blind delete, if you want to allow that through your policies, that's your prerogative, in my opinion, but don't come crying when the returning clause works the way it's supposed to.
It kind of feels like it's harder to configure it to be screwed up like that than to not. And-
Yes.
and
Yeah.
That's kind of an important consideration.
Yeah,
Since
absolutely.
You really have to go out of your way to do that.
Yeah, absolutely. It's not trivial to make that happen, except in stupid, simple cases where you're just doing true, but then,
It does occur to me though that, if you have enough tables and enough policies and stuff, this gets fairly complex.
it can get complex.
So ultimately, you need some kind of an auditing tool for this thing that will allow.
9.6.
Okay.
I mean, but yeah, no, I 100% agree that we need auditing policies and other things. And the other half of this is actually something I'm going to reference at the very end of my talk, which is SE Linux support, right? If you go to SE Linux support, then you can have all very straightforward policies across all of your tables and let SE Linux handle the hard question of who's allowed to actually get access to what, right? Through labels, right? And it actually works already. Yeah, we have it done, but not in 9.5. But we'll be talking about that later. Anyway, all right, well, I'm going to move, last thing before I got to move on, but yeah.
Thinking back to that use case from earlier, having an ending table and a variety of attribute tables, I see that all the create policies can create policy on a specific table.
That's correct.
Was there any consideration given or discussion around the idea of maybe creating policies as an object and then applying, like,
Yeah. There was a lot of discussion about it. I mean, this is how we ended up. There was a lot of discussion about it. It's not what we have today. I'm not sure I want to go back to that discussion. What I think I'd rather do is have something like default policies that get applied, they get created automatically on tables as you create them. The problem with it though is that different tables have different columns.
yeah, but you have that today. Like today, you do that with triggers. You create a common trigger function that you apply to multiple tables.
For the trigger function, but when you actually go and define the trigger, that's on a per table basis.
That's exactly what I'm saying.
Yeah.
One function has
Yeah. I mean, that's.
I found it. I came from Oracle and came to PostgreSQL, and finding that I could do one trigger function and not repeat my code 17 times
Yeah.
and apply it to multiple tables was the greatest thing ever. Right?
So, but you can do the same thing here. You can have a function.
Repeat the same thing.
No. You can have a function, and you call the function from inside of the policy definition. So all of your policy definitions are very simple, like creating a trigger, and you have all the complexity in the function. It's exactly how the SE Linux stuff works. We have a function call inside of the policy. Yep. All right, moving on. So alter policy, relatively straightforward, right? So the alter policy allows you to change the definition of a policy. Big surprise. So here are the options for alter policy. Pretty straightforward stuff. You have the ability to rename them. Obviously you always have to specify the table name because the objects are, the policies are on a per table basis. Not that interesting. One of the things that you can't do is you can't change the command of a policy, right? And that's because of the whole update with check, what's allowed to be applied to what stuff, right? So you can't change, that's why you don't see command in here as an option. Obviously you can simply drop the policy and create it again if you really want that policy to be, the P1 policy to be for updates instead of inserts. You just have to drop it and recreate it. It's pretty straightforward, I suppose.
Just setting it to true also be effectively the same as dropping it?
Yes, setting a policy, setting the using it with check policies to true would effectively be the same as dropping it, except that you probably want to actually drop it, but yes, you can do that too. Here are some examples of alter policy. Again, they're pretty straightforward. You can change the using clause or the with check clause or whatever. I mean, they're pretty straightforward. This is for roles, right? You can change the set of roles that are a certain policy applies to, and you can have a list of roles too. I probably forgot to mention that earlier. When you create policies, you can list multiple roles for that policy to be applied to.
Is it all transactional?
Just like any other DDL in Postgres is transactional, yeah. Okay, not everything, but it's not a vacuum, right? All right, drop policy. Obviously remember that if you end up dropping all of the policies off of a table, we will implement that default deny policy, right? So dropping all the policies off a table is not the way to get to see all the rows in the table, right? The way to see all the rows in the table is to turn RLS off for the table. But this is how you drop a policy, and we do have the if exists support. We don't really have a create or replace kind of thing, but we do have drop if exists. All right, moving on. I had a couple slides here, and I think we've talked through a lot of the different things here, but I just wanted to describe a little bit about how the grant system and the policy system are somewhat different, right? So grant is all about table level actions, and it's also all checks that happen at the beginning of a query, right? At the beginning of a query execution is where we figure out, okay, are you allowed to actually run this query at all, right? And the answer is yes or no, right? You either can see you either can run the whole query to completion, or you can't see diddly squat, right? So traditionally, that's why we've gone to using views to limit data, because that way you can actually have a conditional on it, right? So what policy gives you is this table level row level capability, right? And it's simply a conditional gets added, as I described before. So the one case where we will error with policies, though, is when you do an update or an insert, basically when the with check clause fires, right? If the with check clause fires and you tried to do something that wasn't valid, we will throw an error back. And we will throw an error back no matter how many rows you were trying to insert at that time. Right? So if you're inserting 5,000 rows through values, and one of them violates the with check policy, we're going to blow the whole thing out. Right? So it's a little bit different from how select works, where you can only see certain rows. So it's just something to keep in mind. Of course, you can look at what the policy is and use the conditional from the policy in your insert statement, or make the insert statement an insert select that then has a conditional on it to address that concern if you need to. But just be aware that we will error the whole thing back if the with check policy fires and you are trying to do something that you're not allowed to do through the policy. So here's a couple of examples. This is what it looks like when it comes out when you do a \D on a table. So if there are any policies on it, this is what they're going to show up like. Right? And here you can see I have this policy P1, my user equal current user, and then I'm doing this table T1. This is what the current data is in the table. Right? I'm doing this as a super user, you can see from the hash mark. So you can tell that this is a case where we're doing, I'm just showing off what's in the data. So now I want to actually set role to a different role and see that the results are filtered as I expect, right? So again, if there's no with check clause, because I didn't specify, go back one, there's no with check here on this, but this policy applies to all commands. So we're going to take this using clause and apply it to both cases. So here you can see if I try to insert data for a different user other than my own, I'm going to get this error, right? This policy error. This is actually slightly different now. I did this against an older version of Postgres, older commit, and I didn't update it. This actually now says something about row level policy, right, instead of saying with check. So it's a little bit cleaner now, thanks to Dean Rashid, some of the work he did. Refactoring some of the code allowed us to have a more descriptive error message there for RLS. So here we can talk about data modification policies, right? So here I'm going to set this policy, my user equal current user, again with check true, right? This is that case I was talking about before. I can do blind inserts, if you will. So here you can see I can insert data. It does get inserted in the table, but then I can't see it. So again, just something to be aware of. We kind of talked through a lot of the considerations around that, so I'm not going to go into too much more here. So this is something that I've been talking about a lot already in this, but this idea that we can have this check SE Linux, and this could be my data, or it might actually be like, I don't know, my label, or just label. So everything in SE Linux are labels. So you can actually, if you spend the effort, you can integrate this with the SEPGSQL module, which we've done, and I hope to be able to publish some of that very soon, to actually...
Is it homework for me?
Is it
Homework.
homework for you? No. Well, we're actually going to publish it. We've actually, because we've been able to get it to work. So
Previously I did, but a little bit implementation was different.
okay. Oh, yeah. No, the prior implementation was different. What this implementation does is essentially give you kind of all of the primitive functions that you need to be able to write policies that call out to functions.
Yes, much easier implementation.
Yeah. Yeah, absolutely. So, and we've done that, and like I said, we're going to be pushing that out soon. It won't make 9.5, obviously, because we're far past feature freeze, but the hope anyway is to update the SCPG SQL module for 9.6 to include these primitives, which will then allow you to create policies that can do that, right? So I'm looking forward to that. I think it'll be really neat. Here's just kind of a final, kind of big example, a bit more, rather than those little tiny contrived ones, this is a real, more real, if you will. So the idea here is it's a Unix password file, which hopefully most people are familiar with. Username, password, UID, GID, blah, 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 blah. Right? And then we have these three different roles in the system. We have the administrator, who's allowed to do a lot more stuff, and then we have just normal Bob and Alice stuff, right? So here we're going to first populate the tables, right? This is done as the administrator. We're just kind of setting things up. This is how we build the table. And we have these set of values, right? So we have the username, and then we have the actual name, phone number, some directories and stuff, right? And then we have this enable row security, right? So we're actually enabling the policies, row security on the table so policies will be applied. Then we go through and create our policies. So the policies that we're going to create are this admin all, which says, okay, the admin's allowed to do anything. Obviously, this could actually be simpler. We could just say using true rather than using and with check, but in some cases, maybe you want to do both to make it explicit, right? Normal users can see all of the rows, right? And they're allowed to update their own record, but they can only do certain updates with regard to the shell, all right? This is pretty typical, right? There's commands out there, CHSH, which allow a user to change their shell, for example. This is the same kind of idea here. So this is our using policy that says, okay, the current user, whoever it is, can see their, if their uname is there, then they're allowed to see that, or they're allowed to update that record, right? But when they update it, the current user has to stay the same. They can't change that. And their shell must be in this list, okay? What this allows us to do is it says, okay, the administrator can set the shell to whatever they want, but the user can only set it to this set. And obviously this could be a select statement instead, right? You could go out to another table and select what shells people are allowed to use, kind of thing. So then we have the grant system. So we set all the grants up. The admin gets to do everything. Users only get select access on what I'll call public columns, right? So they don't have select access on the password column in particular. That's the one that you see that's not listed here, right? And then users are only allowed to update certain columns. So they're allowed to update their password, their real name, home, phone, and shell. So when I said that they weren't able to, to have the result be different from this, I think it's a good idea to have that in the policy, although it's not strictly required, because they're not allowed to update that column anyway. So they shouldn't actually be able to create a row where that's not the case. But for my 2 cents, if I was creating policies along these lines, I'd do it anyway, just to make sure. So anyway, so they're allowed to update these columns on password, and moving on. Okay, so now we're going to set role to admin and show, okay, admin can see everything. Yay, yay, yay. Now we're going to see what Alice can do. So we set role to Alice, then we do this table pass WD, and you got a permission denied, right? Alice doesn't have access to all of the columns in the table. That's why you get a permission denied. So Alice has to specify what columns she wants. So here we are, we can specify these columns, and then we can see all the data for all those columns. If I want to do an update password to change my username, as I said before, there were certain things that they're not allowed to do, right? So one of the things that regular users are not allowed to do is to change this column, so we get a permission denied. But Alice is allowed to change her real name, so she has changed it to Alice Doe. Works just fine. Interesting thing though, if she tries to update where it's somebody else, she gets an update 0, right? She doesn't get an error because the visibility policy says that update is not allowed to see those rows. So she simply doesn't, her update runs, but nothing happens. But that's actually why this update only returns 1, too. If you'll notice, there's no conditional here. Right, so this is updating all rows that Alice is allowed to update. Here is the update password. If you try to set the shell to something different, you get a violation of the policy. Like I said, that now says row level policy. Delete, not allowed to delete, so we get an error back. That's from the grant system. This is also from the grant system if she tried to insert into a pass WD some new row, but Alice is allowed to change her own password. And that works just fine. I'm unfortunately running out of time here. This is actually an hour-long talk, but we only have 45 minutes here. But I did want to mention again about leak-proof functions. We talked about them a little bit before. Leak-proof functions are functions that can get pushed down through a policy, same way they can get pushed down through a security barrier view. These are functions that Postgres, we have decided that these functions can never ever return data back to the user, right? Even in an error condition. So those are allowed to get pushed down, and that means a lot of optimizations happen that couldn't otherwise, which is great. We can certainly talk about some of the other things about it, but there's a lot of, only super users can make them leak-proof, of course, and they must actually be leak-proof. If you make a non-leak-proof function, you say it's leak-proof and it's not actually leak-proof, sorry, don't do that. Here's just a quick explain example, sequence scan on that. This was applied from the policy. Here you can see that we are able to use indexes with policies, which is great. Here's something slightly more complicated. You can see here we first apply the policy, then we apply the filter. That's required, and that's the last I had. I'm at 47 minutes, so I'm happy to talk further for a few minutes, but I just want to let you know we do have to get out, and I want to get the next person. Wait, I'm done, but we do have the closing session. Anyway, yeah, questions?
If you disable row-level security for a table and then re-enable it, are your policies still there?
That's correct, yes, policies are kept. Policies are kept even if yes, the answer is yes. Yes? What's that? So there was some discussion about potentially allowing them to be applied to views and being applied to foreign tables and other things, and the answer to that is right now, no. It's something I definitely want to look at, but currently you can't. So it's an interesting idea, but obviously you can put the conditionals inside the view if you want, or you can create another view, or whatever you want to do there. So there's other ways of getting at whatever the problem is that you're trying to address through that, but currently no. Other questions? Yeah, in the back?
How does it work with the column grants? Conflicts or?
I thought I showed that. So the grant system is independent and gets applied. So yeah, you can't do like a select star and if you don't have access to a column not see it. We don't do that. If you select star, you have to have rights across all of them. There's no way to do per column. You can't hide columns and stuff, no. Yes?
Does it completed to include a function owned by unprivileged users?
So if you use a function inside of your query,
No. Unprivileged function inside the policy.
yes, you can have whatever functions you want inside the policy. Same way as you can have whatever query, whatever thing you want inside of a security barrier view. Same thing. So, and we don't worry about pushing that down because you defined it, right? Policy administrator defined it, we're going to use it.
If accidentally include a malicious function, a potential malicious function inside the policy, then a malicious user redefines a function. It may
If,
some problem.
if the malicious user is allowed to change the function defined in the policy, you're screwed. Yes. Okay. Yeah.
I missed it in the example. Does create policies support if not exists?
So I don't think create policy supports if not exist. I could be wrong though. I don't recall offhand. Where was the syntax for that? I mean, obviously you can go look it up, but I don't think we have that. I don't show it here anyway. I don't think we do today. We could add it. Yeah. Yep. Yeah. There's a view. There's a system catalog where everything is, and a view that you can go look at, which tries to make it nicer.
And as usual, editing that directly is not recommended.
Anything what?
Editing the policy on the system catalog is not the way to go.
You should never edit the system. Don't do that. Next. Don't get me wrong, I do updates to PG database all the time, but yeah, it's not good.
There is no if not exists.
Yeah, okay. That's something we should probably add. Yeah.
I saw PG-dump has a new minus enable security option.
Yes.
Which is great. Any possibility of getting something equivalent to no privileges? Like in other words, something to say enable security to filter the data, but don't output the policies so that I can create a filter dump in my database.
Wait, okay. PG-dump has the ability to allow policies to be implemented while you're running, yeah. What is it you need though?
I'm saying as you're dumping,
Yeah.
table definitions don't dump the
Don't dump the policy.
Oh, don't dump the policies.
For both, we have a no privileges for that.
I,
Having an equivalent for no road security.
do we have? I'd have to go look if we had that. Yeah, I don't think we did that, but yeah, it seems like it'd probably be a good idea too. We can certainly look at adding that. Again, probably 9.6 material, but yeah, sure. Any other questions? We only have like a minute left. All right, thank you.